Hello, I'm going over 5-2 today. I don't know what I did differently. Oh, there it is. Okay, solving polynomial equations algebraically. First, I want to show you by factoring. A prime polynomial is one that cannot be factored, just like prime numbers are ones that just have a factor of 1. Numbers that have a factor of 1. Quadratic form, you know it's like standard form, which is highest power first and alphabetically. Okay? So we're going to learn a new way to factor. There are two things. You have seen difference of squares, and that is when you have a squared minus b squared. Two numbers that are perfect squares or variables that are perfect squares, so that means any power of 2. That factors to a plus b and a minus b. Well, now we have two more for sum and difference of cubes. For sum of squares, that's an imaginary number or a complex number. But for difference of squares, you get this. But for cubes, we have this. Now, I will have that available to you and you'll be able to write it down. But there is an easy way that I have remembered what it is. Okay, so if we have the sum of two cubes, which is addition, you're going to have first just your a and your b. So the same thing without the cubes, a plus b. Then you're going to multiply that by a quadratic. A squared, now since we have a plus, this sign is opposite. And then you multiply ab, and then you add b squared. B squared is always added because a negative times negative is a positive. Okay, so that is a plus, sum of cubes. Now if it's difference, again, you're going to take the same thing but without the cubes, a minus b. A squared, now since it's subtraction, you're going to have an addition in the middle, ab, and then b squared. All right? Here are some other factors that we have done. I'll go over what Mateo said. But any number, GCF, you know how to do that. Difference of squares, there's that. Sum of two cubes, which is sum of cubes. We don't say two, usually we just say sum. Difference of cubes. Perfect square trinomials. So these are perfect square trinomials, which these are. Oh no, these are not because this is 2 and this is not 2. Sorry. This is like a plus b times a plus b, which is a plus b squared. And this is like a minus b times a minus b, which is the same thing twice, a minus b squared. Three terms for these perfect squares. General trinomials, which is this. 4 or more terms, you have to do grouping. Remember, you look at these two, then you look at these two. What's common? They both have an x. What's common? They both have a y. So then you take what's common in these, which is a plus b, and then you put your leftovers. So that is all factoring summed up in one place. Let's go over what Mateo said. You could use the sum of two cubes to factor this. Is he correct? Well, a cube, you have to be able to divide that power by 3. A square, you have to be able to divide that power by 2. 6 can be a cube or a square. It matters when you need it. So, yes, that is true. This is x cubed to the 5th. I should write the other. X to the 5th cubed, which is 15, plus y to the 5th cubed. Because when you have an exponent to an exponent, you multiply. Now, if we want to apply this to it, this is our a and this is our b, because that's b cubed, a cubed. So then you just fill it in. You get a is x to the 5th, so I have x to the 5th plus y to the fifth. Then we square a, which is x to the fifth squared. I'm going to write it all out so you see where all the numbers come from. Minus, multiply them together, x to the fifth, y to the fifth, plus b squared, y to the fifth squared. And then I'm going to close that second parenthesis. So what you end up getting, this factors to x to the fifth plus y to the fifth. This is x to the 10th minus x to the fifth, y to the fifth, plus y to the 10th. Okay, and we can because 15 is divisible by 3, so it's 8 cubed. How can you check if, I really like these little questions on the side today. How can you check that an expression is factored correctly? Well, factoring is kind of like division, and division and multiplication are inverses or opposite, if you want to think of it that way. So if you have factors, you can multiply to check. Now with cubes, it's a little difficult to multiply. You have to do the 6 terms this to all 3. Oh, you can't see what I'm writing. And then this to all 3, so you get 6 terms. But you can multiply it and everything will drop out except for x, this plus y to the fifth to the third. Sorry about that noise. Okay, I don't know if you hear it. All right, so multiply to check anytime you factor. So let's do this one. So over here on the side, I'm going to write the formula. A cubed plus b cubed factors to a plus b, a squared minus ab plus b squared. And a cubed minus b cubed factors to a minus b, a squared plus, because that's a minus, ab plus b squared. So you're going to have to work on your cubes. What's opposite a cube? So like this one has 8. Well, what if I don't know what multiplies by itself 3 times to get 8? You have to take the cube root of 8 and you will find it is 2. On the calculator, I think there's a math button, or on the left a button that you could press and you could get cube root of 8. You could also do 8 to the power of 1 divided by 3. So that would be 8 caret 1 divided by 3, and you will get 2. Okay, I have 4 minutes until the bell rings. I'm going to rush through. So this a is 2, this a is 5, y divided by 3 is 4. So there's our a and b. So since it's plus, I have a plus b, a squared minus a times b plus b squared. So this is the same, but this is 2 squared. A lot of people miss that on the test. This is 2 squared and x squared, and this is 5 squared y to the 8th. Okay, I just want to go through this one real quick. Your assignment is a worksheet. I'm not going to go through the other examples because they're the same factoring we've done before. And I only have so much time, sorry. So this, first thing that you should do is look for a GCF. Remember when you're factoring, look for a GCF number 1 and it will show you that the number is cubed. So 54 is divisible by 2 and 128 is divisible by 2. Then I have 2 cubes. The cube root of 27 is 3 and the cube root of 64 is 4. Now I just know that because I've been doing this a long time. Oh, and it's right here. So 2x squared just stays there, carry through. This is subtraction, so I have this minus this. Square this, which is 9, not 3, 9x squared, 12xy, and 16y squared. Okay? Let me know if you have questions, and your assignment for this is a worksheet. Thanks. Bye.